This podcast is just on the basics of covalent compounds, so we'll just talk about what they are before I can start naming them. Okay, so as a reminder, there are three different types of compounds. There's ionic compounds between a metal and a nonmetal. The one we will be discussing is covalent compounds, which is always going to be between a nonmetal and a nonmetal. And the one we won't discuss too much are metallic compounds, which are between metals and metals. So covalent compounds is always between a nonmetal and a nonmetal. So some examples would be water, carbon dioxide, carbon monoxide, and C12H22O11. The street name for that is called sucrose or sugar. Ionic compounds have charges, which we use to balance, but covalent compounds do not. So please try not to confuse covalent compounds with ionic compounds. The molecular structure of covalent compounds varies. There's not one structure that defines them all. There are several. Um, so here we have an example of ionic compounds form these crystal lattices, which is on the left. So they typically have this type of shape. One example of a covalent compound for water is called the bent shape. So there's a lot of different shapes that they can form, but we won't get into that. Just know that they have several different shapes. So covalent compounds, again, form different types of structures. They cannot conduct electricity when dissolved in water. So if you ever put sugar in water, you'll find out it does not conduct electricity. Most are insoluble or does not break apart in water. They have very, very low melting points and low boiling points. And they're usually dull and breakable. So think about plastics when you think about covalent compounds. There are a few elements that you need to be aware of. They're called diatomic molecules. Every element on the periodic table can stand by itself, like Na, sodium, Fe, but these elements cannot stand by themselves. So when we talk about oxygen, we always write it as O2. Oops. So make sure you understand it's O2. Nitrogen, when we talk about nitrogen gas, it's always going to be N2. Hydrogen is always going to be H2. The best for you to remember it is I call this the L plus one. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, plus the one way to the left, hydrogen. We always call them diatomic molecules. They will always form covalent bonds with themselves. This becomes really important later on when we start balancing equations. So, one case study of a covalent compound is oxygen. Here is what oxygen looks like. It's sharing bonds with itself as a covalent compound. Its melting point, and oxygen can be a solid and it can be a liquid. So the melting point of oxygen can be negative 218 degrees Celsius, and the boiling point at which it goes from a liquid to a gas is negative 183 degrees Celsius. So it really illustrates the low melting points and low boiling points. And here in this picture we have a example of liquid oxygen. So that's just a quick overview of the basics of covalent compounds.